By putting a custom harness in every meaningful part of your workflow and not just at the root of your project, you can squeeze dramatically more intelligence out of your agents. Basically, general purpose harnesses are built to handle broad use cases and messy realities. They are not optimal for any one task because they need to be decent at all of them.
The next step is to treat harness engineering as something we do at every meaningful section of your project, and to do it even for every sufficiently hard task. An agent should not just have its own job to do, it should have its own world.
Welcome to Superlinear, a podcast about emerging practices for building with AI agents.
Each episode, we cut through the noise to find one new angle worth trying. Then we unpack why it matters, where it works, and how you can apply it in your own workflows so you can build more powerful things.
We're your hosts, Christine Yip
and Brandon Kase.
In this episode, we will briefly review what we mean when we say harness engineering. We will talk about what if you deliberately built a harness in every meaningful part of your workflow, and even between sub-agents in the same prompt and not just on the top of your work tree. We'll also talk about when you have to narrow the capabilities of your agents and how to enforce behavior instead of just hoping that the model will follow your instructions. So we've all probably experienced an agent making mistakes, like ignoring instructions or repeatedly producing poor results. And often the way we respond is by adding more instructions. For example, we clarify the prompt, we create a skill, or we paste in more context, or we write another role in agents.md. And sometimes this all works, but it can also turn one general purpose harness into an increasingly large collection of guidance that every task must carry around. And Brandon, I know you and I talked for hours the other day about this, and you have a lot of thoughts about it. Have you run into this as well?
Yeah, we have to remember that the models have a certain amount of attention. So the more things that you put in context, the more distracted they get, right? So
that makes sense.
If you're blindly shoving things in your agents.md whenever there's a mistake, if it's something that's rare, then you're distracting the agent when it's doing most of its other work, which is not good. I think a lot of people have started to do better. They're starting to do progressive disclosure of information. So if you're using skills, for example, then your agent will only pick up the skill if it's about to do something that is related to that skill, unless you manually include it. And there's other ways to do this. You can have a directory of different markdown files and pull them in as needed. So, but this is only one half of the problem, because as you know, listener, or maybe as you might remember, agents get their context, one, from these feed-forward guides, markdown that we're inserting ahead of time, but also from sensors, from things that are giving feedback, from tests that are running, from code reviews, things like this. So these are giving feedback into the agent after they take certain steps. And that's also adding to context.
Yeah, I know we talked about this in our episode 3, the latest episode, but basically guides are things and context that the agent gets before it starts its task. And the sensors are the things that the agent get after the task. And that would give, for example, test, lint rules, right?
Yeah.
Okay, cool.
After steps, basically. Yep. So
okay. It makes sense what you're saying, because also just to remind myself, because if you put I like how you said some skills you could only invoke them when the time is right, because a bad example would be to put it in the agents or Claude.md, because basically every agent or sub-agent that you spawn will also read that markdown file, right?
Exactly.
So I guess the problem is not, hey, the model needs another instruction, but sometimes the model needs a better world, like you said, or a better environment.
Right. Exactly.
Awesome.
Instructions are just part of the environment. They're just part of the world. But there's other parts in the world too.
Gotcha. I would love to dive into that. And I think to talk about that, we need to dive into harness engineering. And I know you are jumping to get into harness engineering. Maybe before we dive into this different way of thinking about harness engineering, can we first tell everyone what we mean when we say harness engineering? Like what are the things exactly that are included in the harness?
Yeah. So when we say harness engineering, we mean the coding agent harness, Claude Code, Codex, Pi, maybe an SDK, how that's customized globally, and a layer on top of that, how it's customized for your particular project. This is how people typically talk about harness engineering. That plus other guides and other sensors. So the markdown that's part of agents.md, any skills, any other reference files, even things that are automatically generated, but inserted ahead of the agent doing its task. And then the sensors that are relevant for your project or your system, like every time I run git commit, automatically run these tests. And if there's a test failure, exit loudly and it redirects the agent.
Gotcha. So the harness can be very broad. Like it's not only the prompts, not only the project instructions and the skills and even the tools, but I think you're referring to like it's much broader, like tests, oracles, hooks probably as well. Maybe profilers, plugins, permissions, sandboxes, like everything in that environment. Is that right?
Yeah. So I think this is important. When we talk about harness engineering, we can unambiguously just talk about this whole thing. If you just say harness online, different people will interpret it different ways. But the community has come together and there's a consensus definition for harness engineering, which is to mean that all that stuff as part of the harness that we're engineering, which means we're sort of taking care and setting all these things together holistically to build a system that helps us when we're solving our problems.
So it sounds like if you do harness engineering really well, you can push performance way higher than what a bare model can do. And I remembered from our earlier conversation, you mentioned that you listened to an interesting discussion as part of another podcast that you listened to. Yeah.
So you're going to listen to a clip from the Moonshots podcast, one of my favorite podcasts, where Dave Blunden is discussing that if you engineer your harness in a particular way, you can basically destroy this particular benchmark.
That is, unless Anthropic was benchmarking on Arc AGI 3.
Okay.
Well, I think that scaffolding argument, though, is really, really important because if it holds up, I tried to replicate it, because you can get 98%, I guess, on Arc AGI 3 if you give it a reframing of the way it interprets the puzzle.
Right.
And if that holds up, that gives inspiration to a billion entrepreneurs who can take something like protein folding or drug discovery or mechanical design of robot arms and say, Fable 5 can do this, or Opus 5 can do this, but I gave it a better way to think about the problem. And now I tripled its intelligence within that.
So Dave used the term scaffold, but he means harness in this context. So as we heard, your harness, getting your harness right for a particular problem set, for a particular focus, can push your performance way higher than even an incrementally smarter model can. What we saw was going from Fable to Opus 5, and even Opus 4 to Fable, is dwarfed by having your harness set up properly with one of the dumber models. So what does this mean? I mean, basically, one, this is why harness engineering matters, and it's why lots of people have been talking about it. Okay.
Yeah, indeed, because it was not only the folks on the Moonshot podcast, but we've also seen people discussing this on X. I saw Dax from Open Code and Anthropic staff also touching on this topic. Maybe we can pull up that tweet.
Yeah, let's pull that up. So Dax is quoting something from the Anthropic staff. So let's pull that up first. So basically, Jess is saying here, this is the relevant statement. I think I'm quite biased, but I also think that it is impossible to get the maximum performance without tying together the harness and the model. Now, it's important to note that she's talking about harness in the context of Claude Code, and specifically in the context of a general purpose harness. So Dax is quoting this, okay?
Mm-hmm.
He's saying, people want to dunk on this by saying their weekend harness does better on some dumb one-shot benchmark. But at scale, this is true. These tools are complicated and must factor in user behavior. And on and on and on.
Mm-hmm.
So what is he saying? If you're trying to build a really good general purpose harness, it's hard.
Mm-hmm.
It's hard. And what you get is you get something that is pretty good at everything, but it doesn't one-shot benchmarks.
Mm-hmm.
Now, Dax is saying this, saying, oh, people are trying to build these harnesses and they're thinking they're good because they can one-shot benchmarks. But I think that's the wrong take. What the other way to look at this is to say it's possible to one-shot benchmarks by building a specific harness. This is the point of harness engineering. Make your harness specific, right? And people have. Let me close this. There's a big consensus these days around harness engineering, and we also talked about it last time.
Mm-hmm.
But people, when they talk about harness engineering, they're talking about the harness at the scope of their project. What matters is specializing the harness to your work, to your task.
Mm-hmm. Just the way how Dax was describing, if you specify it, if you adapt it to that specific benchmark, it will perform way better. So why don't we do that for our specific tasks? And I think that definitely makes sense. I can imagine how this could apply in our own workflows. Mm-hmm. Like a lot of projects that probably a lot of people work on, like a single project can contain very different kinds of work. Maybe there's a part that's front-end implementation, there's back-end architecture, there's performance optimization, maybe there's 3D modeling or data migrations. And why should all of them use the same harness, right?
Exactly. And I know, if you're like me, maybe you've come across these kind of one-off instances through your work, and I'll show a couple of them. But it wasn't until this week that I realized, actually what we should be doing is thinking about harness engineering holistically at these finer grained levels. So in order to maybe help you understand what we're saying, we can pull up some examples. Yeah?
Yes, please.
Okay. I'm gonna start with a solution to a problem that I've seen people talk about for months. I responded to a tweet even yesterday about this. And it's something that you can solve in different ways depending on the kind of work that you're doing. So what is the problem? When I want to run multiple subagents or agents in parallel that do the same work, what do I do if that same work is dependent on a shared resource? So to be more specific, let's start with iOS. I want multiple agents to be testing in an iOS simulator and doing builds at the same time. Well, by default, that doesn't work because by default, these things they conflict with each other. And so this was a project I did in January. In my harness, I have something that says that has a configuration per agent.
Just for the listeners who who are listening on Spotify and don't have video, what are you showing exactly on the screen?
Yeah, sorry about that. So what I've pulled up is a terminal window, and I've opened an iOS project that I was working on. And within that iOS project, I'm going to open up in agents.md and just show you at the top of here, it says agent 1 simulator configuration, and then there's a bunch of stuff. And there's a lot of these like hard-coded things in it. But what this is saying is it's giving the agent some specific commands that it can run to have a conflict-free access to simulators. And the way that I set that up is I have a script, which I've stored in the scripts folder, that is run by every agent to get a unique environment. And when you do that, then you're able to run multiple iOS simulators at the same time. So this is an example of how I've set up the harness. Yes, I've put some stuff in agents.md, but I've also created tools to help me isolate my environment so that I can have multiple agents running in parallel to build my iOS app. With my harness engineering hat on, I would, and if skills existed at the time that I did this, I would put this into a skill,
right? So
that it doesn't have to pollute the context and waste attention for agents that are not using the simulator.
Gotcha.
Yeah, I think this example is interesting because a lot of examples are just about context narrowing. So it's like turning off the right tools, turning off certain guides. But the harness that you're building up through harness engineering, it's not just about what goes or doesn't go in context, but it's about the whole environment. And in this case, this is about configuring the execution environment. It's setting up the execution environment to be able to run in parallel.
Gotcha. So I guess this example is more to show what can we set up in that environment to really help this agent to succeed in this specific task. Okay, now I get it.
Exactly. And I'm going to just I can quickly show an example of this same thing on the web. And this is exactly the same thing, but for a web project, because I keep seeing people struggling with this. If you want to have concurrent sessions with, let's say, like the Chrome DevTools MCP. So what I've done is I've shared the docs from Chrome DevTools. There's a section on concurrent sessions. There's a certain amount of flags that you pass in. And there's some instructions here. You can feed this to your agent and ask your agent to set you up a harness to set up your environment so that it behaves in this way.
Oh, cool. So yeah, we will add the link in the description too. So people who are only listening can find it too and watch later if they want.
Yeah. So that's, I think it's just an interesting example. This is an interesting example that came up in the past for me that doesn't have to do with context narrowing. But context narrowing is a big part of it. So, and we even have a whole section on context narrowing later.
Yeah, this is a very interesting example where I like it. It's a good example that shows how you can give an agent the right tools specific to that task. I'm wondering, because when we had our conversation previously, we also had a few other like general examples. Maybe we can show those now too. And for folks who are only listening, maybe we can just voice over them just to give people a little bit of, give them more sense of how this could be applied for different kind of use cases.
So what I've done is I've shared a diagram. And this diagram says front-end implementer environment. What this agent needs in order to build UI well. So this is for tasks that involve the front end. The kinds of things that you're thinking about when you're designing your harness, when you're engineering your harness and you're iterating on your harness for this specific focus, you want to understand what the goal is. And then you want to think, okay, what is the context here? What are the things that I need to specify in files and pull them in? In this case, design systems, reference screenshots, for example. What are the tools that I need? What are the tools that this harness needs to be able to control? maybe if you're doing front-end web, you need browser tools. You need a way to take screenshots. You need a way to write code. And then there's automated checks. These are like your sensors that run in a hook or as a result of certain commands. So for example, you might want to do a visual diff or an accessibility check or an integration test. And then you want to think carefully about your definition of done, the criteria that the agent can use to check that it's actually done with its work. So that's you can derive that from the goal. For example, in this case, it's like making sure that there aren't any accessibility issues, that the reference screenshot that you passed in is the same as a screenshot in the web. And if you specify that, you can add feedback loops into your harness that, for example, you can say, keep going until the screenshot is in place, right? So
Yeah.
So this is like a simple front-end example. I'll just really more quickly talk through a few more.
Yeah, how would the environment for other kinds of agents look like?
Yeah, so here's for maybe a performance agent. So I'm sharing a new diagram here. It's helpful to think in these categories. So what's the goal? What context do we need? Tools, feedback, exit criteria. I'm not going to talk through all of these specifics, but I'll pull a little handful. Context might be a baseline measurement of how fast something is. Tools, you might want a profiler. The feedback might be the benchmark results, and the exit criteria is that the benchmark result hits a certain point, for example. And then I'll just pull up one more. So this is a debugger agent. The goal might be finding the root cause of a bug. Context might be things that you've seen, things that you've tried, repro steps. The tools, you might want a debugger. This is like similar to the thing I talked about last time, where I built a custom debugger for debugging my Game Boy projects. Yeah, and then and so on. So
this is very helpful. This really helps me also see, like when you mentioned, build a world for your agent specific to that task, how that could look like. It also just a quick side note. It also emphasizes or shows me how a harness is much more than just a skill. Like skills are very useful, but a skill is usually just additive. It gives the agent instructions, knowledge, examples, or maybe tools. But the harness, the environment that you just described and showed is much broader. It can add capabilities, but basically it can also remove tools, restrict permissions, or narrow available context. So I guess maybe that brings us to, is more capability for the agents always better? So we talked about what should the agents have in their environments, but also what should they not have? And the reason why I ask is because I got inspired by Tariq's post. Maybe we can pull that up. Yes. So Tariq, I think it was a week ago when he sent out this post where he told Claude Code users that he simplified the Claude MD file, and I think he cut away like 80% of it. But this does not only need to be applied to context engineering. You could also think about this from the perspective of harness engineering, right?
Yes.
What do you think?
Yeah. I think this is a really interesting thing to think about. So removing parts of your markdown files is one thing, but let me pull up another tweet that was inspiring, or that inspired interesting thoughts. So this is a tweet by Matt Pocock, the creator of famous skills like grill me, etc.
Not drill me.
Not drill me. Yeah. So Matt posted this tweet the other day, and I think the important part is here. The specs my skills create are intended to be deleted immediately, not kept around or treated as source code. And he further clarified in a response, and there was some discussion on this, that this is because it poisons the context of your agent. Because so the spec is used to derive the code the first time, but as your agent starts iterating on the code, as you make changes when you're reviewing, as you add more features, the code and the spec starts to drift, and you can try to keep them together, but it's tough. It's tough, and it's not only about being careful not to put that context automatically in your agent's context, but even having it in your repo, in your folder, is enough to poison the mind of the agents. So this is actually a real problem that I've been experiencing, and didn't realize that I should do something about it until this week. I have been checking in my specs, and frequently in the reasoning of my agents, when I'm working with my agents, I see something like, "Oh, I thought the spec says this, but when I went in the code and I tried to change it, I noticed that actually the code says this other thing. So I'll just forget what the spec says." That reasoning trace is polluting the mind of the agent. It's distracting it from its work. And so actually thinking carefully about how accessible is that information, even if it's not there, if it's accessible by the tools that the agent uses to search around, then you're still at risk of getting your context poisoned. And I think there's one other example of this. I mean, the same sort of thing, but so I use Beads, Beads Rust, which is a tool for task management. At some point, we'll probably talk about this in more detail in an episode. But the same thing, I had a conversation with a friend the other day, and he was saying, "Oh, how can I use Beads but not check in the beads?" And I'm like, "Hey, that's the point. Like, you want to check it in because you know that information is useful. You can do all sorts of analysis on your data and these kinds of things. But it's the same problem. If it's available and it's a spec, basically, it's like a description of a task, not the actual result of the task, then that can poison the context of your agent. And that then leads to this idea of, okay, well, I should have two separate harnesses, two separate environments. In one environment, I have access to all the historical beads, all the historical specs, hopefully, ideally, the reasoning traces of all my chat history, and I can do retros in that environment. And in my environment where I'm actually implementing my work, I need to get rid of all that stuff. It needs to not even be available and accessible to the agent. This is something that I only realized this week.
So what? Okay, no, that's super helpful, because I could see the context pollution point, and also how removing them can improve the work itself. Because basically, agents have finite context, they finite attention, they finite tokens, and finite compute. So every irrelevant spec or document loaded into the context will compete with something that is relevant. So, and also, like, every unnecessary tool that we introduce will also add another possible direction. So every generic instruction the agent must carry through the trajectory will consume attention that could have gone towards solving the actual problem.
Yep. And you might think, okay, I'll keep my specs separate, but it's not just specs, it's code too. I want to show another tweet that came up recently by Victor Talin, the creator of the Bend system, a prolific tweeter. So Talin noticed, he has long tweets, so let me highlight the relevant part. He was begging the AI to remove and rederive the work, but noticed that this does not work. It has a massive bias to keeping what is there. So he talks about how he spent so long trying to get Fable to just not not keep what's there, and he couldn't. And then he realized it can't keep something it doesn't see. So what he did is he adjusted his harness to remove the parts of the code that he wanted Fable to rederive, and only include a description of what it's meant to do, and that fixed it.
Interesting. Do you have any examples? Like, when would you want to hide parts of the code? Like, what parts of the code would you like to hide?
In this particular case, so Victor's working on a core kernel for his new like proof. What is it? It's like a proof checker in programming language, and he's really conscious to keep the code and the complexity as small as possible because the problem is already.
Mm-hmm.
And also, when the code is simpler, it's easier to optimize. So, so he has a part of that code that he felt is too messy, and he wants it to be cleaner. And so I guess, like, in general, if you're refactoring, if you have some part of your system where the code is messy and that messiness is making it hard to understand, both for you and for your agents, it's making it hard for new features to get added in. It's making it hard to optimize. This is a technique, a practice that you can do to convince your agents to rewrite it. It's just get rid of it and only include a placeholder, rather than having it there and telling the agent that you need to redo it. One more thing before we move off of this. So we talked about like specs and plans, how that can pollute your environment if it's included in the wrong places. We talked about how code in the wrong places can ruin your environment for certain tasks. But even sensors, even tools that run automatically, tests that run automatically can pollute your environment. And how is this? Well, every unnecessary sensor slows down your agent. And as our agents are getting faster, as we're willing to accept dumber models that run faster, we are controlled by the grips of Amdahl's law. Okay. So I found the article. It was not a tweet. It was an article. So this was on the front page of Lobsters today. It's a post by Martin Alderson. The title is "I'm in parentheses mostly picking models on speed now, not intelligence." So the whole point of his article is that he is reaching for dumber models that run faster. But here's the interesting part. There's a nice diagram that he built, which is an illustration of Amdahl's law. Let's talk about this diagram first, and then I'll explain Amdahl's law. Okay. So what is this a diagram of? On the bottom, on the x-axis, you see seconds per agent turn, and the y is just a bar chart. So there's two bars. At the top is a bar that's 50 tokens per second, and you see this bar chart. It's broken up into sub bars. At the bottom is inference, and then tool calls, and then U. So inference is the time that it takes to do inference. Tool calls is the time it takes to wait for a tool to run and then get the result back. And then U is the time it takes your brain to think about what happened and then decide what to do next. And the interesting thing here that's counterintuitive, which is a consequence of what is called Amdahl's law, is if you compare the bar chart at the top, the 50 tokens per second one, and the bar chart at the bottom, the 250 tokens per second one, this is a rate of inference speed. And so in this graph, or in this diagram, the author shows inference take 40 seconds at the top and 8 seconds on the bottom. And that's a 5x speed up in the model speed. But the tool call speed and how fast your brain thinks does not change. And so on net, your agent only speeds up by 2x. So a 5x increase in speed in tokens per second is only a 2x increase in your agent speed. And this is Amdahl's law in action. So Amdahl's law, I'm not gonna explain it in detail, but essentially it's it relates the how fast your speed up of some section of your work is to how fast you can realize that speed up in the whole system. Because basically, if you have some fixed amount of time for other parts, that's staying the same, but it's becoming a larger percentage of the total time. So, so what's the point of this? How is it relevant to what we've been talking about?
Yeah,
well,
because we were talking about having a lot of tests, right?
Yes, that's exactly how it's relevant. So yeah, as the models are getting faster, as you're willing to pick up faster models, if you actually want your agent to be faster, you have to make sure to shrink the tool call time as well. And that's not just getting your tools to be faster, but it's choosing which tools you need at any specific point. That's the point.
So going back to how we started talking about this topic, about the Amdahl's law, that when there are so many tests in your own projects that have been accumulating over time while you were building it, you shouldn't keep all of them. Is that what you're
exactly?
Or you shouldn't run them all the time for every agent.
So this is just one kind of sensor. This is one kind of feedback that you have. But let's use this as an example to ground ourselves. Yes, what's happened to me several times in my projects is I have my agents write tests as they go, and I have all the tests run automatically after each task so that there's no regressions. But what happens is the test time starts building up and up and up, and it's slow.
Yeah.
And this is a problem that people might have run into in the olden days before agents as well. It's just more acute now because the tests are running more often. And so it's important to take a step back and saying, okay, which test do I actually need for this part of my work? Which tests can I run in parallel? Which tests are actually duplicates of each other? So it's worth like going back and that's part of the effort of like tending to your harness engineering garden that you should be doing all the time. And I guess in the context of our conversation now, you should think about these environments distinctly even within a project.
How could you actually implement that in practice in your workflow? How can you, for example, in my current workflows, I also have like almost 4,000 tests. How can I tell my agents, what is the best way to tell my agents how to group them or filter them? And how do I even like hide certain files from some agents?
Yeah. So for the first part, for grouping tests, that's just a prompt. So open a fresh prompt and in a fresh harness, tell your agent, okay, look through my tests, benchmark them, tell me if there's any that are duplicated, parallelize where you can, and you can just work with your agent and fix that, because that's applicable for everything. So that's one step that's easy. The second part, actually removing them. There's a few ways I can think of to do this. It's not something I've done yet myself.
Oh wait,
since we just discovered it.
Before removing them, when we ask the agent to help us categorize or filter the test, probably it's not only the duplicates, right? Because, for example, some tests are more tests that touches front end, some others touches the back end architecture. So how would you tell the agent to make a distinction there?
Yeah, it's funny. This is actually something that I spent a lot of my engineering career solving in different companies, and there's lots of different ways to do it, and there's different like levels of complexity you can go in. So like we said, this is a problem that has existed for a while, and so there's solutions. So a simple thing you can do is for each test, you can assign which part of the code base it's associated with. And so in somewhere where you're registering tests in your script that's running the tests, you can work with your agent and say, okay, match this prefix for these tests. And if that prefix doesn't match of like files or folders that were touched in this change, then you don't have to run those tests. So that's a simple thing that you can do that your agent can probably one shot. Does that make sense? So let me be specific. you could say if you have a front end directory and a back end directory in your test runner, your agent would change it for you to register tests that say like, okay, these are all the tests that run if a file is touched under the front end folder. And these are all the tests that run if a file is touched under the back end folder. And if you touch a file in both the front end and back end folder, then all those tests are going to be run. And that's exactly what you want.
And you ask the agent to make the decision which test needs to be run when code in a certain folder is touched.
Yeah. So you can work with your agent and decide, okay, these are tests that are important for front end. These are tests that are important for back end. Then you tell your agent, okay, label them and put it into my test runner so that they run automatically in those situations. So that's a really simple thing you can do. There's a problem with that approach though, which is it's something that you assign, that you make a judgment on, and your judgment could be wrong, or it can go out of date. And so that's where this breaks down. So the other way to do it, which is much more effort, but there's a bunch of test runners that go the other way around, where your whole build and test system is built around the idea of understanding the boundaries and the surface area of all of your code files. And so when your build system understands that, it natively knows which tests are associated with which modules. And this is something that there's tools like Bazel or its derivatives, Buck. These things are sort of, you have to buy into them, opt into it. If you use Nix to set up your project, that's another tool to look into. But these are very heavyweight, and you'll have to invest a lot of energy in, or you'll have to change the structure of your project. Agents can do that for you, so it's not that much energy. But it's also not always possible. If you have in your project code that has a lot of different programming languages, and you're doing lots of bespoke custom things, it can be really hard to fit them into these frameworks. So
it sounds like it might be better if you use the second method, that you just start building the project in that way instead of trying to implement those later.
Yeah. That's something you can do up front. And with the agents, it's not even that hard to change in the middle, to be honest. But it's,
I'm just worried about mistakes or misses and gaps.
Yeah, the thing that I would discuss with your agent when you're trying to dig into this, if you're listening and you want to play with it, just talk to your agent about the trade-offs of these different approaches, because you'll be limiting what is possible when you have your tests set up that way, where it's like all tracked by the build system tracks it. But the benefit is it's perfect. Like if you change this line of code, it knows exactly what tests are associated with it, and nothing else will run.
Awesome.
So yeah, so that's how to do that side of it.
Okay, then, I could also imagine if the second option, I don't know, is not an option for some people, and they go with option number 1. You could also add a retro step and run a loop to make sure that any test that you have missed the first time will be captured afterwards.
Yes. Yeah. You can have a review agent run periodically to make sure that things are still aligned.
Awesome.
Yeah. And I guess, and then there's one more piece, which is, we talked about actually making it impossible for the harness to see the code or the files or the context. How can we do that? I don't have a great solution. I think to do this, so to do it kind of in an ad hoc way, it's easy, right? You just move the file, and that can be enough a lot of the time. I mean, the example I showed with Victor Talon, he just deleted that part of the code, replaced it with a comment, and that can be enough. I think there's an opportunity to build some kind of tooling around automatically showing and hiding or exposing and removing from your execution environment, your sandbox, the specs and plans and tasks, issue tracker, that kind of thing. I don't know of a tool that exists for that. So for now, what I've been doing so far is just manually moving files around.
But if you're like in our examples that we mentioned during this episode, we for example, we talked about front end agents and agents that work on maybe the backend architecture.
Yeah.
I could imagine that you want to give the front end agent maybe the style guide. But when the backend agent is working, you might not want to remove the file, right? You do want to you don't want it to pollute the backend agent's context, but you don't want to remove it and then hopefully you won't forget to re-edit again when you tell your front end agent to do work.
This is the thing to set up. It is like we saw some examples where you do need to remove it because even it existing is going to distract your agents because they'll pick it up when they're searching for files. So, more concretely, like a simple way to do that, if you're already using work trees, so if you use Claude or Codex, it's just a checkbox when you start a session. If you're using the app, you'll have a fresh work tree and you can just delete the files. And then you have to remember, or you tell your agent like, "Hey, don't commit these." But yeah, even then they're sort of visible. So I think there's an opportunity to build tooling to automate this more.
So even if you spawn a sub agent and you specify exactly what files should be shared with the sub agent, you think maybe since they have access to the files, like what Victor Talon said, they might still access it in some way.
I guess in Victor's case, it was in the same file. In the example with Matt Pocock, the specs were just living in different directories, and I've seen it happen. The agent, when you tell it change this part of the code, it looks and finds a spec that describes it, and then it loads into context even if you didn't tell it to. And so, yeah, it existing is a problem. I think you can probably, you can hack your way around it for now. You can just delete the files and maybe add something in your prompt that says like, don't look at them. but that's not a good solution.
Yeah, it's an interesting insight and practice to think about though, because sometimes after building it, maybe you don't need the spec anymore, and then the way how you described it, move it to a different directory that only the retro agent or some other agent who really needs it can access it. That makes sense. Yeah, definitely worth thinking about, even though there's not a mature product or tool built yet. Yes, and since you mentioned, this isn't new to many software engineers. It's just more acute now. I guess another practice that a lot of software engineers have already been doing, especially those who focus on security, is limiting the blast radius. That could also be another reason why to narrow the scope or capabilities of your agent, right? Could you maybe, yeah.
If you when we say blast radius, we mean like when we have an ask, how much of the world gets destroyed by the blast of the bomb. That's sort of the metaphor. So like how many files are touched, how much stuff has changed. And so it's good practice to limit the blast radius of your actions when you're using multiple agents in parallel, or just in general, because you have less change to review and there's less chance of something to break. And so the best way to limit your blast radius is to remove the parts of your environment from the world, and then the bomb cannot touch them because they're not even there.
Right. So, for example, if I was building an agent who would check my CRM to decide which clients I have to contact or reach out to, then give it only read access. Don't give it only give it read access. Don't let it edit the database.
Yeah. This is that's an example of a of like the danger the danger argument, which is also something. I mean, we haven't really touched upon that. It is something that a lot of people talk about, I suppose, but it's another part of the harness. So yeah, as you're saying, like we've seen people accidentally lose their database, delete their hard drive. These are examples of a harness that's not carefully guarded.
Yeah. And maybe, don't even give them the tools that they don't need. Like don't give that CRM agent the tool to send out emails if you only want them to propose which people to email.
Yep, exactly.
Cool. So yeah, I guess it's narrowing. So I guess when designing a harness, it's good to ask yourself, what information does this agent genuinely need? What tools will really help it complete its task? What feedback or test should it run automatically? What should it never be able to do? And then the goal of this all is not to create the most powerful possible agent that can do everything, but it's to create the agent that most likely can succeed at a very specific task.
Exactly.
Awesome.
Perfect.
Okay. Cool. Then maybe this is a good point to also move to our one of the last things that we also want to touch on, and it's also very important and interesting to touch on. We talked about how narrowing the harness can help the agents make the agents work better. But sometimes mistakes still happen. And there are probably also different ways of enforcement that we can apply. Yeah, and that reminds me of something that I was trying to do with OpenClaw in January. I was building this personal agent, and I wanted it to help me schedule my day based on my calendar and my priority list. And but when I first tried to build it with a simple prompt, I learned that it sometimes does not follow the instructions or missed things. And I remember that we talked back then as well. And after chatting and discussing it, I realized there are actually different layers of reliability.
Yeah. Tell us about the layers.
Okay, so there are 4 different enforcement levels for agents. That is, level 1 is prompting. Level 2 is using templates. Level 3 is using scripts. And level 4 is cron and heartbeat triggers. So level 1 is natural language instructions. For example, wind down work by 8:30 p.m. And this is fine for tone and communication style, but it's not reliable for anything where accuracy matters because the agent will only follow it most of the time. And that's not enough.
Right. Yep. Okay. And then what about level 2?
Level 2, using templates. So you could force your agent to use a structure that it needs to fill in before acting. For example, I told my agents, check the calendar and fill out this section. And the section is calendar output and then blank section. And if that section is empty, then the plan does not get sent to me because then it means the agent did not do a good job at checking the calendar before sending it to me. So that's a forcing function to make sure the failure becomes visible.
Right. And then OpenClaw would get that feedback loop. That makes sense. And then what about the next layer?
Yeah, level 3 is using scripts. So this is actual code. I wrote a bash script that calls Google Calendar. It parses the JSON and then outputs a clean time block, clean time blocks that pre-calculate the free windows. So then the agent can read the output instead of interpreting raw API data. And a script cannot misread a meeting time or forget to check. So that is another enforcement level that's even more reliable.
Great. And then what's the last one?
Yeah, the last one is cron jobs and heartbeat triggers. So you could also use external triggers that fire on a schedule. Then the agent does not need to remember at all to, for example, plan your day or send you a reminder at at a certain hour of the day. The cron job will just fire and force it. And the heartbeat, you could also have a heartbeat that pulls every 30 minutes or something. And I found that after I use these different layers for different things that I wanted my personal agent to do, finally it started to be reliable enough for the task that I gave it. And I could also imagine that these kind of enforcement levels could also be applied to harness engineering.
Yeah, I think so. The this like nomenclature I think is really interesting. There was a post by John DeGoes this week. I'll just show it quickly. Your old agent architecture is dead. Meet its replacement. John DeGoes is the CEO of Zyverge Tech. He's the creator of ZIO, which is an inspiration to Effect, and just in general, like a functional programming guru. And anyway, this post is interesting, but in the very beginning, he introduces this concept of hope and then how to fix it with enforcement. And I think that's like the best lens in which to look at what you were sharing regarding OpenClaw. So
cool. How would you describe the different enforcement levels when people are building harnesses?
So there's you can think of it like a sliding scale between hope and enforced. So at all the way on the hope level, it's all in Markdown. It's all context driven. It's all non-deterministic. It's all what will happen will be generally what you want, but maybe not exact, and depending on how complex your ask is. And this is what you were seeing with layer one. And then as each of those layers that you described is moving us more and more towards enforcement, towards determinism, towards software 1.0 that does exactly what we want. And ultimately, the best designed harnesses are doing as much as possible in the determinism side, essentially, with speculative evaluation, with branch prediction. I'm just using metaphors here, but with also guidance on the hope side. So this is exactly what we talked about in the last episode. But just briefly to say it again, if you only have the determinism, if you only have your rules that yell at you if you do something wrong, then the agent is likely to do it wrong first and then fix itself. If you only have the guidance in agents.md, a lot of the time it'll do what you want the first time, and sometimes it'll fail. And so we want the best of both. We want to most of the time do the correct thing, and in the cases where we make a mistake, we correct it. So that covers us to the layer 2, I think. And then that last layer that you talked about, the trigger, this is just another part of the harness that we haven't talked about yet. So how the agent actually starts doing its work is another thing that you can control either non-deterministically by an orchestrator, or if possible, deterministically with a cron, for example, that runs on a timer and automatically, deterministically always does that task at a certain time.
Yeah, I definitely notice when you go the deterministic route, your success rate is much higher than staying on level 1.
And this is exactly why context engineering is not enough, and we need harness engineering. Because if you're thinking in terms of context engineering, you're only in that hope world. You're changing your agents.md. Maybe you're making lots of skills. You're making lots of different Markdown files. But all of these are hopes. All of these are non-deterministic. All of these work sometimes, but not all the time. And you need that, old school code. You need that determinism. You need real software that's checking things and doing things and triggering things. And that's a really important part of the harness, and we can't leave that out.
Yeah. That 100% makes sense. I think I learned that when the cost of failure is higher, then the system should depend less on hoping that the model remembers a certain sentence in one of the Markdown files. I could also imagine that maybe sometimes not every smaller task needs a custom environment. Yeah, I could imagine that maybe for a one-line copy change, building a whole environment would be absurd.
Yeah. And
yeah. How would you describe like the type of situations to spend more time on designing the harness?
Yeah. I think this is also a scale. So let's talk through the different endpoints and then the middle. So like you mentioned, on one end, if it's a one-line copy change, don't waste your time with this. It's low stakes and the cost of the mistake is minimal. As on the other side, the complexity grows, safety becomes more paramount, more important, and I guess in that side, in that world, it's worth spending a lot of energy and a lot of effort on your harness and actually taking the time, building it, thinking carefully, going through loops, the human agent feedback loop, and getting something really good before you start your task. And then there's stuff in the middle. So something that actually John mentioned in his article that I started playing with, and it seems to work. You can, you don't have to design the harness yourself. You can just tell your agent to do it. So you can, for example, create a nice sub-agent graph where the first step is to have a bootstrap agent build a harness for you for your task. And that I found works well for these in the middle cases. So you have a reasonably complex problem you're trying to solve. Maybe the stakes of making a mistake are not too high, like it doesn't send an email to your boss with something rude in it. But you're changing some code. You're doing some large task, and just asking your agent to do this for you is something that's helpful.
So it sounds like the amount of harness engineering should scale with factors like the difficulty of the task, the cost of failure, maybe the number of different failure modes. And probably I could imagine that if it's a recurring class of task, you might want to invest more time on building a reusable harness.
Yeah, that's a really good point.
Yeah, so it sounds like that not every subtask needs the general purpose harness and the elaborate infrastructure. Building the right harness that is better adapted performs really well on a specific task or bottleneck. So that is where the large productivity gains can come from. So I guess the takeaway is match the harness investment to the task. Is that right?
Exactly.
All right. Okay. Well, maybe to wrap things up, when setting up the environment for our workflows, what we often do is we set up the tools, the skills, the context, even hooks for our entire workflow. And we will have all our agents and sub-agents reuse all of them. But hopefully, after listening to this episode, you're asking yourself also another question. What harness could we build that is adapted to this specific task and makes the outcome better? Or what environment would make it hard for that agent to do wrong? So that question might change how you think about doing harness engineering from here on out and how you focus your harness on the problem you're working on. Well, this was episode 4 of Superlinear. We hope that you got something out of this episode. Have a lot of fun with harness engineering. Please tell us in the comments about what you build and what you notice in your approach. Brendan and me are learning as well. And we'd love to hear about what you experienced in your workflows. And don't forget to subscribe so you don't miss out on our next episode. Thank you all and see you next time.
Bye, everyone.